Okay, and now I'm going to do the Toolkit tutorial. I think this is the last tutorial that we need to do before we go back to Robotropolis. So I'll do this, and I don't think this should take too long. The Toolkit. With what you have learned so far, you can make robots do a lot of simple tasks, but to get through the higher levels of Robotropolis, you will need to make circuits with parts from the Toolkit. Notice that the cursor has changed. This cursor can be made hot. You'll see how soon. This circuit was made by connecting wires between the inputs and outputs of two parts from the toolkit. Use the remote control to stop and start the flow of electricity in the circuit. You can see if I keep pressing R, turn the circuit on, turn it off, turn it on, turn it off. The remote control starts and stops electricity both inside and outside robots. It's a pretty powerful remote control. Imagine if you had a remote control that would turn on and off all the electricity in the world. I'd like a remote like that. It's hard to see where the wires connect in this circuit, but you can fix that. Pick up one of the parts. When you move around, the wires will stretch to follow the part. Indeed, they do. If I pick up this node here, see how the wires change? The wires will change to follow the part as you move it around. This is true of a lot of schematic editors as well. If you use a schematic drawing program in real life, usually they will automatically adapt lines to follow parts as you move the parts around like that. So that is kind of like real life. However, the wire will break if you stretch it outside the room. So if I pick up this this NOT gate and come out here, the wire no longer is maintained. So you can't wire across rooms. This is the toolkit. Inside are parts you need to wire circuits. Take the toolkit into the next room. You can open and close the toolkit by pressing T. Try it a few times. Leave the toolkit here. So I'll drop the toolkit here. It even supplies a helpful arrow to tell me where to drop it. And I press T. See? Press T. And if you keep pressing T, it opens and closes the toolkit like that. Toolkit open. Toolkit close. Open. Close.
Now we are open. And now close.
Okay, I'm going to leave the toolkit here for now. No toolkits allowed. And this sentry bot exists for the sole purpose of blocking us if we're carrying the toolkit. See, if I pick up the toolkit and try to get through, the bot grabs us and carries us back. And that's the only reason for the bot being there, but if you drop the toolkit there, we can get by the robot no problem. Okay. If the toolkit is nowhere in sight, you can summon it to you. Think of it as sitting in your pocket wherever you go. That's going to be an awfully large pocket to fit a toolbox inside, but okay. Press T to summon the toolkit. And there we go. I press T and the toolkit magically appears. Drop it and press T again to open or close it. And there we go. There's the toolkit in all its glory with all the stuff inside it. Each part in the toolkit is really a stack of parts. The numbers in the toolkit show how many parts are still available. This toolkit is partly empty, but a full toolkit has 10 flip-flops, 10 FF, 15 nodes, 15N, and 35 gates, 35G. Open toolkit here. So I will summon the toolkit and drop it right here. And now open the toolkit by pressing T. So this toolkit has 9 flip-flops, 13 nodes, and 29 gates left. That's not bad. Enough for the tutorial anyway. You can take parts in and out of the toolkit with the cursor. Take a part out, move on top of it, and press spacebar. To put it back, drop it anywhere in the toolkit. Watch the counters change as you take parts in and out. So if I stick the toolkit here, and now try to open it, see, I can pick up this flip-flop. Right now we have 9 flip-flops, but if I pick up one, it goes down to 8. And I can take as many flip-flops as I want, up to 9 obviously, since that's how many are available in the toolkit. And if I pick up one of these and put it back in the toolkit, there we go, back up to 7, 8, back up to 9. So you can take things into and out of the toolkit as you like. Moving on. The cursor here is special. It can be made hot with electricity to test parts. Press H to make the cursor hot. There you go, see the cursor turns purple. Pass the hot cursor over the antenna input to turn the antenna on. Going to do that now. See? That input lights up when I pass over it. Press H again to make the cursor cold. Oh, it's a cold cursor. You can also use the hot cursor to move a robot. Just sit on a thruster input and the robot will move. The hot cursor is available for testing circuits in the Innovation Lab. Unfortunately, you can't use it in Robotropolis. It would spoil the game. Well, it would make the game a lot easier. I don't know if that would spoil it, but... The next room is called the Crossroads. From it, you can follow various paths to learn about the different different parts in the toolkit. Okay, let's start off with nodes. Oh, it says turn the remote control on. Okay, so let's go and look at nodes. A node makes electricity branch to two places. Take a node from the toolkit and carry it to the next room. So I'm going to put the toolkit down here. I'll grab one of these nodes. There we go, see, that's a node. Where the input of the node, the circle or the center of the node is the input, or the input of the node to the output of the contact sensor. Okay. So I'm going to start here, run a wire from there to the output of this contact sensor. Wire the node outputs to the thrusters, like so, and like so. Drop the blue key so that it touches the sensor. Electricity flows to both thrusters. So I'm going to drop the key right about here, and both thrusters turn on. So basically all the node does is it's just like a Y splitter. It basically splits off a signal into two branches. Pretty straightforward, right? I think that's it for nodes. Flip-flops. In real life there are several different types of flip-flops. There are SR flip-flops, D flip-flops, JK flip-flops. In this game there's just one kind of flip-flop. A flip-flop is like a light switch. It flips electricity from one output to the other. Take a flip-flop from the toolkit. And, okay, hold on, let me do it out here so that the toolkit doesn't occupy too much of that room. Okay, I'll grab a flip-flop from here, carry it with us, and I'll drop it right there. Take a flip-flop from the toolkit, put the hot cursor on one input at a time to make the electricity flip and flop. Okay, so I'm going to press H to make the cursor hot again. And watch what happens. Right now the right hand side of the flip-flop is on, but if I touch this input, the left side turns on. If I come back and touch the right side turns on. And the cursor is just not quite wide enough for us to hit both inputs at the same time, which is probably a good thing because that would... You know what? I'm curious now. What happens if you turn on both inputs at the same time? It's an interesting question. I've never tried it. You know what? I'm going to try that now, just as an experiment. Now I'm curious. I'm going to grab this NOT gate and wire it so that it connects to that input. That input turns on, but now if I get another NOT gate and wire it so that the other input also stays on, what happens, I wonder? Nothing. The flip-flop gets confused, and it just stays where it is. Okay. Go inside the robot and wire the orange output of the flip-flop to the thruster on the right. Sit on the eye to see what you did. Okay. So right now, this flip-flop is off. I'm going to connect it to this thruster and sit on the eye. And you see that we just made a ping-pong circuit. The robot goes left until it hits a wall, and then goes right until it hits a wall. Because when the left bumper activates, it turns on this input on the flip-flop, which then triggers the left thruster. And then when the right bumper activates, it triggers this input on the flip-flop, which turns off the left side and then turns on the right thruster. And you can see the circuit actually at work. Because even though we're off the eye, we can't see the robot moving, but we can see the wires reacting inside the robot, which is kind of cool. So there you go, that's a flip-flop in the game. And like I said, in real life there are different types of flip-flops. We're not going to worry about that now. This isn't a course in electronics engineering, it's just a course in Robot Odyssey. Logic gates, you know what? Logic gates come in 4 types, and or, not an XOR, or exclusive or. There are 35 logic gates in the toolkit. The 35 gates can be all one type or any combination of the 4 types. And the only difference between... basically you can see there are 8 types of gates here. The only difference between this one and this one is that this one points upward and has the inputs at the bottom. This one points downward, has the inputs at the top and the output at the bottom. So basically 4 types of gates, but because they can point either way, you end up with 8 gates, 8 gate types in the toolkit. You know what, I'm not even going to review these gate types because I've gone through this way too many times. There are NOT gates, there are AND gates, there are XOR gates, and OR gates. I'm going to skip that because I've gone through that explanation way too many times. I've seen way too many explanations of logic gates already. If you don't know what they are, should I explain it? Maybe I'll explain it later. For now, let's just consider the toolkit tutorial over. Now you know what the parts in the toolkit do. To find out how to make simple circuits inside robots, go back to the menu and select robot circuits. Yeah, maybe I'll explain the gates another time, but for now they should be pretty intuitive. I'll explain them. You know what? I'll explain them as I use them in the game, because I just can't stand another tutorial on the different types of gates. I've seen that way too many times in real life, so I'll leave it at that. Okay, that's the not the sensors, the toolkit tutorial. And that's the end of the tutorials for now. Thanks for watching, everyone.